This is the third in a series. Is this the last, or do you have more? One more. There are 4 parts. So if you missed the first 2, you're going to have to catch up, and you'll be confused until next time. Let's give them a big round of applause.
Thank you. So yeah, this one I kind of have a warning. There's a lot of smaller text because I put a lot more commands and everything in this one. So if you want to follow along, you can go download this. I put like a PDF up there too, or download it later and just believe what I'm saying if you can't read it. So we're on level 3 now with the attacking Active Directory series. This time we're kind of post getting our first shell when we're inside the network, and now we're going to start doing some recon and identifying those attack paths. This whole thing kind of started with this, like kind of I got my Yoda Zen comment here in order to effectively defend ourselves, we need to understand how these attacks occur. I talked to a lot of domain admins after pen tests and such, and we see them buying a lot of products and worrying about things that are like very specific in their networks when they're just missing like major things and they don't know what their own users are doing, you know? So I'm trying to show that like there's not like 0 days we're flinging around here. We're just kind of guessing some easy passwords and then just taking a quick and easy path right up to domain admin. So today we'll do a quick little review, and then we'll do host recon, look at network recon, and then talk a little bit about some stealthy considerations and some protections, and then a couple different tools to kind of do all this stuff. So the first talk was kind of explaining this whole process the attackers have once they get some credentials. They're looking for high privilege users, and they're looking for, if they don't have a high privilege user's access already, I'm gonna find out where I can go with my current user, migrate there, and then run things like Mimikatz and steal other users' passwords, and kind of keep this process going until we get some domain admin creds. It's kind of like this attack path where you have Bob, the attacker got on Bob's machine, and then we find that John has a session on a machine Bob does, and so kind of following like what Dustin was just talking about with Mimikatz, that's kind of what we're doing. We're stealing those passwords off those machines, but we're also going to be looking at where their sessions at so we know which ones to go steal passwords from, and then work our way through the domain until we get a domain admin. Next we talk about initial footholds, which a lot of times is a lot easier than finding some exploit. We do just guessing some easy like summer 17 passwords, which meet most default AD cred password policies. And then kind of from there, you can do VPN access, Citrix access, or use Exchange and use that tool like Ruler and get a shell that way. Then we talked about the command and control kind of setups, where the attacker's machine, we kind of talked about like the good, better, best setup. And now we're on to today. So host enumeration. Starting with host, we're gonna go to network next. Host enumeration, what are the goals? So you get on a host, obviously you wanna steal passwords, but not just in memory. We're also looking for passwords in files, password managers, stealing them out of the browsers. Then we're going to try to do some profiling, because with a single host we can kind of get some idea of what software is in the network, what antiviruses they're running, and any other maybe like potential targets, like if we see they're running JBoss or other like out-of-date software we can kind of profile. We'll look at firewall rules for our shells that we're talking around the network, or if we want to get outside the network, we can kind of fingerprint the firewall. We'll be looking for other users. We want to really get their session keys and what type of session key they have, and their passwords also sitting in memory. And then we're also going to look at the sensitive files on these machines, like the .configs or .properties, or a lot of people we find that have just a password CSV in a folder called passwords or something on their desktop. And then maybe SSH keys, because we're not just looking at, I know the series is focused on Active Directory, but sometimes what we want isn't in Active Directory, it's in the Linux databases or something, and we might want SSH keys or something like that. So from here, we're kind of assuming that we've already owned a machine or owned a person, we've got credentials, we either spun up a VM and joined it to the network, or found like they had Pixie boot or something enabled, or we just got a shell right off the bat. I didn't really cover catching the shell originally, but right when you get a shell initially in Empire, I don't know if you can see that at all or not, but you kind of get some of that host info right away. So it gives you an agent name that you can interact with. It tells you the internal IP you're on, the machine name, the user you're running as, and then when you first interact with these hosts, the first thing I typically do is run sysinfo. I kind of run sysinfo like constantly while I'm using Empire, because Empire's, it kind of beacons back and asks for like what the next command is. It's not like interactive like Meterpreter, and so I'm always constantly thinking something killed my shell or whatever. So sysinfo is a good one just to run. That'll just pop this info out to make sure your shell's still kind of valid. But this will give you the IP, the domain, and the user, or if you're running local, like you can kind of identify that. The Windows version, you can usually assume if you're on a workstation that a lot of the other workstations are going to be running that same Windows version. For any kind of privilege escalation you might have to pull off later. It tells you if you're high integrity or not. That kind of comes into play later. And the PowerShell version. This will tell you kind of the lowest level PowerShell version that it'll support. Ideally, you want to be as low as possible because they've been adding more and more logging to PowerShell as it's gone up in versions. We'll talk a little bit about 6.0, which kind of just recently got pushed. But version 2 is ideal for what we're going to do. So after that, we're going to look at the network connections. What we're looking for here on a host, it's like looking at the routing tables, looking for open ports that you can possibly use for other exploits if there's services running somewhere. RDP or SSH connections may indicate that this box is going to have some keys on it or sessions that are saved. A lot of people just save all their RDP sessions with the creds already typed in, and we can just steal those and use them. Things like netstat are kind of going to get you this info. And you can also kind of help identify the IPs and ranges inside the network before even doing any kind of scanning, you know? So in Empire, you can run any command like you would at a normal command prompt by typing shell and then the command you want to run. So like this is just running netstat on a box. This gives you that internal IP information. You can look at the local services running, internal connections to other box with like NetBIOS names or IPs. And this is all kind of like before you're sending any traffic to the network. You know, you're still trying to stay a little bit quiet here. Same thing with identifying the RDP sessions and open ports. Next, we're looking at sensitive files on the host. Ideally, I tend to look at .configs, .properties, anything with passwords in it, SSH, AWS, RDP keys, any kind of loot we can get off of one host. And then like scripts or PowerShell scripts, especially like with admins, they have a lot of migration scripts or something built in that have hard-coded passwords in them. Anything we can do to find more access through the network later on. Empire makes this part nice. They've got a find interesting file command or module that you can run that by default like kind of does regex searching on the whole host for you, and it searches for paths and sensitive and admin and XML files, virtual machines, anything with creds in it, login, secret, credential, .config. That's kind of like the defaults. You can add your own as you kind of build that list. But this will just kind of output all those files right away. And you can, on a host enumeration, you can run lots of these commands manually yourself. Like you can either enter a shell or just use different modules. But Empire makes this nice with a few different modules that'll do kind of the whole sweep in one shot. WinEnum is one of those. It's in the situational awareness /host/WinEnum module. This grabs the AD groups, the last 5 files open, interesting files. One that's kind of cool is clipboard contents. Like if anyone's ever copy and pasted that password out of a password manager or whatever into a form, like we can pull those out of memory. It'll also find like services, available shares, more stuff like AV fingerprint. It all outputs just in a nice little text file for you. The last Windows update that occurred and when. If there's different network adapters, any established connections, any mapped drives, and the firewall rules on a host. And it's nice because all this stuff is we're going to kind of just keep building our kind of arsenal of like what we can go after and what this network has in it. The And I mentioned firewall rules just because you can run these things individually too. Like this firewall rules one, they kind of just create a firewall COM object that points to the actual firewall, and then they enumerate all through that firewall and grab all its configs. Computer details is another just module built into Empire that pulls the logon events, and these are great for servers if you're not sure if like DAs have been there before, or it'll kind of give you the history of all the login events from the Windows event log. It'll tell you about any RDP connections, and it'll also pull all the PowerShell scripts that are custom made on the machine off. And a lot of times people save their PowerShell scripts that maybe log into other devices, or you can pull a lot of information out of these things that will help you look at the network later. And then it also just, I don't know why it kind of adds that in, but it'll pull processes protected with AppLocker. Kind of a funny one, but I kind of get it, depending on who you're up against, is the Paranoia Mode that you can run Empire in. This kind of sets up a scheduled task that will continually check for any users you define, that like if you know someone's going to be hunting you, it'll alert you, and you can either like kill off your shell or give it some command to run. By default, it'll check if any DAs log in while you're on a host. And then it has a giant list of processes that they've built over time that are different like IR tools, so you'll know if you're getting investigated or someone's looking at you. And another one is that it checks if any processes are running off USB drives. So that's like another way, like forensics teams will come in and plug in their tool and start kind of investigating without touching the file system. But we can look at the USB drive and see if there's any bad processes looking at us there. There's lots of these host modules in Empire. Tab completion is kind of your friend here. Look at situational awareness / host. There's a couple different modules there. There's also these collection modules. These are more for like, they've got like Chrome dump and Fox dump, and those are things that'll kind of like Mimikatz, but they'll pull the passwords out of like, if you have passwords saved in Chrome's kind of built-in password manager or Firefox, you can set up keyloggers, you can set up webcam recorders, you know, all kinds of weird, creepy kind of stuff, really. You can do packet captures, which can also kind of help with enumerating the network, but you're still just on a host here. And then any kind of file vaults. They've got some for KeyPass. I don't think they've got like LastPass or anything yet, but I know someone's probably working on it. Then we're going to get into processes. And we'll talk a little bit more about processes here. Processes are going to be important to look at because first of all, you'll be able to tell if there's other users running on this box. And then the architecture type, which sometimes like Mimikatz or things like incognito to steal tokens, like you need to be in a 64-bit process or a 32-bit process, depending. Also from the processes, you can grab the software and the antivirus there. And when we talk about defenses, you can also find out if like ATA or ATP is running on these devices. And those are things that will catch you doing certain stuff. So a process listing, you can do it the simple way, like in Empire with a PS, that works in Metasploit too. Or send a shell command like WMIC, which is the kind of preferred way currently for attackers. WMI is not yet able to be logged. That's part of the PowerShell 6.0 push stuff. But you'll see here when you type in PS, you get users, then you get the architecture, and then like what processes are running where you can identify software or antivirus. Now these processes are important because they're all going to have tokens tied to them, and tokens come into play when we want to start, maybe we can't get the passwords from someone, but we can imitate being somebody. And these get a little wordy here, but I'll try to explain it. Like, you can kind of think of it as like a lock and key, where the ACL, which we'll cover in a second, is the lock, and then like you present your process token as the key, and then you can either access a resource or you can't. And like every object in Active Directory is going to have one of these ACLs or locks on it, and then all the processes is going to have the right key to be able to access that stuff. When a new process gets created, it gets a security token associated with it, and that contains the information, like is it running in an elevated user context, and it'll also contain what privileges that user has, like the SE debug privilege I use as an example. If it's enabled on a token, then that token can debug a service running on, as a local system. So with the process tokens and the security tokens we'll be looking at, it kind of matters on the network logon type. And I know they use non-network logon, and it kind of gets confusing because you're on the network and you did a logon, so why is it a non-network logon? But really the main key thing to take away is that non-network logons are used like when you RDP into a machine and it prompts you for creds. You're not already have the rights to get that access, so you have to type in credentials that'll be able to give you a ticket so you can access the thing. Network logons are like if you have shares mapped and you can just go access those resources. Well, your user's already got a token that will access that, so I don't need my creds to go get a new token to do that. And why that's important is because there's impersonation tokens and there's delegation tokens. I know this gets a little deeper, but like when you're going to look at a machine and processes, you want to look at what type of tokens you have available to you, because when we start moving around the network, it's going to matter, because if you have an impersonation token, that token means they came in with a network logon, and that token's only good for whatever it asked when they came in to this machine, however they logged on. Like they needed to access a file, so that token might only be good to access like that file as that user. Delegation tokens means they typed in credentials, so we have those credentials with us, and we can then basically act like them on the network as a whole. And if that user generally has local admin access on a bunch of boxes, I can use that delegation token then to get that local admin access on those other boxes. And if you've ever heard of get system on Metasploit, it's kind of like the easy way, like once you hop on a system, you type in get system. Kind of one of the ways it does to get system is you're not actually becoming system user, you're actually just grabbing one of those impersonation tokens from a process that's running a system and tying it to your own security context. It does like 3 different other ways too, but that's just kind of one of them that's part of it. In Empire, it's a little bit more difficult, and you kind of have to know a little bit more what you're looking for, but they do have the like credentials tokens module that you can look at. It'll output, when you first run it, all the users and tokens that are on a machine. So this is still like just on the host. If you see a process running by some guy and you want to see if you can become him or act like him on the network. And what we're really getting to is like, if we find a DA, we can just drop in using the DA's token and then do something like a DC sync and never leave our host to grab all the passwords off the whole domain. So Empires gives you a pretty detailed output where it gives you like the privileges that token has if you want to do different things. It's a little bit easier in Metasploit to kind of see and understand. There's a module if you have an interpreter shell up called Incognito, and it's fairly simple from Empire to create a Meterpreter handler and kind of pass off to Meterpreter or Metasploit your shell. So you'd load up Incognito and you can just list tokens, and they just straight tell you like, here's the delegation tokens we have available, here's the impersonation tokens. What we want to do is impersonate one of those delegation tokens, and then we're essentially running on the domain as that user. And that really just ties back to how they originally logged on. Microsoft's current I think recommendation is to use PowerShell remoting with like just enough administration, or like you run in like constrained language modes. That way you don't take your delegation token with you. You only take impersonation tokens, and so if they steal that, or it doesn't take any actual credentials with you, so Mimikatz won't find anything, they won't be able to go anywhere with your user when they steal it. It's kind of a pain to set up just enough administration because you need profiles for every box, and then you need to limit what PowerShell commands can be run once you get onto a host. But that's kind of how you can do adminning with a domain admin but not get your cred stolen. Now, I'm going to try to cover ACL, ACLs, DACLs, SACLs, and ACEs, and SOs and SDs here, which gets a little bit deeper, but I'll try to make it easy. So SOs and SDs are securable objects and security descriptors. Every securable object has at least one security descriptor, and everything like in Active Directory basically is a securable object because they're all going to have permissions to access anything. Some common ones are like processes or threads. network shares, Windows stations, desktops. And with these acronyms, so an ACL, an access control list, is just an ordered list of ACEs. ACEs are an access control entry, so any entry on the ACL is going to be considered an ACE. The DACL is a discretionary access control list. This identifies the users and groups and what permissions they have. The SecKC is a little bit less looked at, but that sets up different logging events on particular items. And so it's kind of you can trick your way into creating something like a canary token. Canary tokens are kind of a way I've seen for like blue teams to kind of identify, like they can set up a system access control list on a file and then get an event log whenever that file gets accessed. So you drop something like passwords.txt on someone's desktop, set up logging on that file so that if anyone accesses it, it'll throw an event log and you can track like, hey, someone shouldn't have grabbed that. That was a fake file that we could use to catch them. An SD can contain two ACLs. The DACL and the SecKC basically are those two ACLs it can get. But you've probably seen these before and maybe just didn't know what you were looking at. So if you right-click on a folder and pop it open and go to the security tab, you're actually going to be looking at these ACLs. So the DACL is kind of the top half, and that's listing those users and groups for that folder. And then whenever you like click on one of those names, below it'll show you like what permissions that user has, whether they have read, write, if they can list this folder's contents, if they can have full control, and like those individual entries are part of the ACE, which is the access control entry. If you click the little advanced button at the bottom, it'll take you into the ACE inheritance. And this is later when we look at Bloodhound, like you can run Bloodhound and there started looking like, oh wait, there's all these inheritances we weren't really looking at originally when we were scanning the networks. And so they started collecting all the ACLs for like everything in the entire network and then look for even more attack paths for us. So we don't really have to know why and how all this works, but I just thought it was kind of cool. Like you've probably seen this before, you just didn't really know. The SecKC is on that auditing tab, and that's where you can kind of see, you can set up your security like event logging on any particular device. And so it might be a little bit confusing, but that's okay because we don't really have to know. I tried to come up, I was talking with some guys at work, like how can I explain this like in the easiest possible way, and someone told me it's kind of like when you're trying to get into a club. So we've got Club AD, okay? And the ACL is the bouncer, right? He's gonna say who can get into the club. The DACL is the clipboard he's holding, because it's got the list of names of people that can get into the club. And then we've got the SecKC, which is the VIPs list, because those guys get like paparazzi with them, and they're kind of like logged wherever they go. The ACEs are just the names on that list. And then the impersonation tokens, you can think of like a stamp that gets you into the one club, and the delegation token is like a wristband that gets you to like every club in the strip. So hopefully that kind of brought ACLs, DACLs, SecKCs, and all that together somewhat in like the worst way. But that's host enumeration. Now we're on to network enumeration. And what we're really trying to do is just identify these attack paths throughout the network. We kind of figured out the profiling. That's used a lot when on the host for all the antivirus, because like a lot of the commands here, they work in certain environments, but you might have to do tricky ways, like some of like compiling them with the .NET to JS stuff, or a lot of that is where like the actual like pen test work comes in, where like things should work. You have to find like the 50 workarounds to make your one Mimikatz actually drop and run. And we're really just trying to identify these attack paths through everything so that we can easily get our domain admin. So the goals are to find those privileged users, where they are, who they are. Then we want to find our current users, or the current user we have, or the users if we've been gathering them, because we're going to kind of continually gather more and more credentials as we get through our pen test. And then we want to find identify the paths to those privileged users. So like how can those groups and nested groups, how can we get our way to that domain admin? By default, there's a bunch of privileged, or they call them like kind of like tier 0 accounts. Basically, even though all these aren't necessarily a domain admin, there's like a route to domain admin this way. Something well, if you're an account operator, you can like add yourself to every possible group in the whole network, and then from there, you might not need domain admin all the time to get whatever you're after. You know, like if you're just trying to get the loot or something from like a financial company, you maybe just need to become a part of the financial group, and you don't even need domain admin actually to get there. You can get this manually with stuff like PowerView is a good one. It's part of like the PowerShell Mafia PowerSploit package. Those commands you can run straight on those hosts. You can find your local admin access. The local admin access, kind of as talked about before, is important so that you can actually like run Mimikatz and pull those passwords. You can invoke like a share finder to see where all the different shares are you can access. There's a check admin option for that one, which is kind of a trick way of finding if you've got local admin by requesting the admin shares on all the boxes. And then you can get like your local groups and enumerate local admin. PowerView can also chain these commands together. He kind of mentioned these download cradles, which I'll explain a little bit more. The download cradles were, like I said, invoke expression is basically what the IEX is at the beginning. And I think I tracked down that it stems from a Raphael Mudge talk on continuously staging external PowerShell scripts. He was using it mostly like in Cobalt Strike, but when you're on a host and you want to import these modules, like how are they doing that? But basically you're creating this .NET run space instance that provides an execution context for your PowerShell pipeline. There's a link at the bottom if you want to go watch that original talk. It's called Flying a Cylon Raider for some reason. I'm not exactly sure what he was getting at there, but that's where kind of like maybe the first instance of download cradles came up. And a normal download cradle is kind of just the default one. And these are the ones that are getting caught a lot more by AV, where you just invoke that expression, create your .NET instance, and then you download whatever that string is. You can either host that on GitHub, or PowerShell Empire hosts it all locally and reaches back and grabs it off itself, basically. Harmjoy has a whole like gist of different and like upgrading, getting harder and harder to detect ways of doing these download cradles. Daniel Bohannon is the guy who wrote Cradle Crafter and Obfuscator, and that will generate these download cradles for you in already pre-obfuscated ways that you can then run just right away and pull in scripts into memory and never touch disk, and then bypass any antivirus signatures or anything looking for them. So back to the chaining the commands together, you basically use this cradle to pull in the PowerView script, and then in the second half, just kind of separated by colons are your getNet domain, getNet forest trust, and getNet domain trust. That would be kind of mapping out your current domain, any other domains in the forest, and then which way the trust directions are going. I won't really cover cross-domain trust exploitation. That gets a little too deep, but I also wanted to mention that you can also just write these PowerShell functions right into PowerShell. Like you can compile them yourselves, build the function, and then run it. Like this is an example just of a get local admin that will query all the computers and try to find the administrators for those computers, see if you're in that group. For the network enumeration, really what you're just gonna do is you're gonna list all the groups in the domain, you're gonna list all the privileged groups specifically and kind of write these down, and these are the things you like tape up next to your face, so you're always looking like, if you're on any machine and you notice one of these guys, like that's whose credentials you want. And then you're gonna wanna ID the DCs just for later. DC sync's kind of the latest way of getting creds because you don't actually have to log into a DC, but you might have to for some reason. You can do that with simple things like netgroup domain controller /domain or netgroup domain admins. Those are getting caught with the latest Microsoft stuff, but only those Windows 10 enterprise users are going to have that, so it's usually not an issue for me. User Hunter is another PowerShell script that we can call in, and this will just basically only go look for all the sessions of all the domain admins. It'll query for the domain admins and then try to find where they're logged in at. And like I said, we're looking for all the users, and we're looking at local and domain users, because we can't forget that a lot of people use like a golden image to create their first domain box, and that local admin password is then going to be the same on all of our domain boxes. So we can maybe just use his local admin password or hash to log into all the boxes on the network and pull all the domain users off. We're going to look at all the groups, local and domain, because yeah, again, we might not need an actual DA to get whatever the attacker's after. I mean, they're not always after your all your passwords. And then we can also list out all the domain computers, and there's lots of different modules and manual ways of doing this. Or we can run the kind of new fun tool Bloodhound, which I have talked about a little bit before, and some of these slides are a repeat if you've seen this before. But it's developed by Waldo, Captain Jesus, and Harmjoy, and then there's a lot more contributors now. There's like something like 100 contributors. They have a pretty active Slack too, if you guys are on Slack, that has a lot more like red teaming and some of the Empire channels in there, and crap map exec, which we'll talk about in a little bit. But it's a really good tool for the red teams and the blue teams. It helps us quickly identify all those paths that we're kind of trying to find. And it outputs these nice little graphs for us that show us like the hops that we need to take to domain admin. That's kind of the overall goal of what we're going for here. And like kind of in this picture, those little green dots that you can't really see are users, and then the yellow dots are groups that they're in, and any little red dot is a computer. But sometimes you'll see that like you don't even need to log into like one computer if you have one user, because he's nested in a group that's nested in another group that a member is a part of, that's on one box that's got a DA on it. So we might only need like one user and one hop to jump to DA. And it's going to look at all those ACLs, the ACLs, DACLs, SACLs, all that, for a lot of these more really complex and inherited classes that aren't as obvious to most domain admins. And it can find these really highly complex ones in big environments, and I've showed this one before. I think this was run on like one of the domains at Walmart, and it just showed like so many past the domain admin. I don't know what Tim Malcolm Better or whatever's going to do over there, but they got a lot of work, I think, ahead of them. So to run Bloodhound, I didn't quite cover that in the first one. It is built into Kali now, so you can kind of apt install it, which takes care of the Neo4j setup for you. Raphael Mudge, the Cobalt Strike guy, also has a blog post on setting all this up that works pretty well. But essentially, the one thing that kind of catches me, or I see people doing, is like when you first launch it, you have to go to the local host for Neo4j and change the password the initial time. It doesn't like, it's like when you first log in, it gives you like a change your password screen. Once you do that, then you can launch Bloodhound, and Bloodhound will work. Now Bloodhound works kind of in two ways, where it's got the one interface on your host attacker machine, and then on the domain joined machine is where you're actually going to run that PowerShell script that runs Bloodhound and does the get computers, get local admins, and gathers all that data for us. By default, this thing is going to output 3 CSV files. It'll just drop them to wherever you run it. You can set up Bloodhound so that the Kali instance is listening, and then this will actually just pipe all the data straight to your Bloodhound instance. But it's just as easy just to drop those 3 CSV files to that user's desktop or whatever, and then just download them. In Empire, you can just type in download in the file, and same with Metasploit. And then in the Bloodhound interface, you're going to import all these files, and then it'll build your maps for you so you can query for the domain admin. So on that victim machine, you can use like the Cradle, same idea, where you pull in Sharphound is kind of the latest. They kind of like rewrote it in C# to make it like faster or something. But it does work like a whole lot faster than it used to. Like large domains used to take like 30 minutes to gather all that data, and now it takes like 5 when you're talking like 10,000 different hosts and users. Or just use an Empire module where you can just navigate to Bloodhound, say execute, it'll tell you where the files are, and you can just download them right after. Then back on your Kali instance, this is where Bloodhound's actually like the interface is running, the Neo4j instance, you'll import these things, and then you can just start searching like, I want domain admin, and it'll show you like all the paths available. You can also type in like the user's credentials you currently have, and then see if that user already has a direct path to domain admin. This can be useful because you can also look at computers that you've owned, and go pick on those and see like who's got sessions up, where they're at. Really like everything about the domain is now going to be in here. There is like, so what if you don't have a domain join machine? Can you still do any of this? So like one of the ways we got in was we guessed creds, but we used a VPN to access the network. So maybe we've got our Kali machine, but we don't have actually a domain join box that we've hacked. That's where I want to talk about CrapMap exec. It's kind of the Swiss Army knife for pen testing. They make heavy use of impacket and powersploit. And this thing is pretty sweet. It does like everything you can imagine off your Kali host. It does contain Bloodhound. It can generate Empire launchers for you. And if you have creds, it'll log in and shoot an Empire launcher back for you. It's got host and network enumeration modules. It can run Mimikatz for you. It can do the token stealing and token usage. It talks over WMI by default, which is the ideal one to be talking over lately. But it can also use PSExec or just PowerShell remoting. Kind of to show you this, like this is running it to retrieve the password policy of a domain, where it'll just kind of jump in with like SMB, get the password policy for you and pull it back. This one is like spraying your logins. A lot of times when we're earlier on gathering all those domain users, it's not just to find the domain admins. We want to grab those domain users too, because maybe we don't have a path to domain admin right away, but the same password attack we tried on the outside, we kind of had a small list of emails or users we could find. Now we've got the full list of domain users, and we can try that same password attack and probably pop a few more people with summer 17 and fall, or I guess we're into 2018 now, but it's surprising how many of those work. And one cool one dealing with Mimikatz is you can also spray Mimikatz. If you've got local admin on a bunch of machines, you can just use this to like, it's very satisfying. It's kind of a little bit overkill, but to run Mimikatz on a /24 and just see like 255 like credentials all come raining back in for you. And CrapMap just kind of lets you do that. So the defenses for some of these things that we need to watch out for. Microsoft has been definitely taking that assumed breach, like we're not going to stop these guys, there's too much. Let's start looking at what our current users are doing, because now they're just guessing passwords and logging into our networks. ATP, this kind of comes from Blue Hat in Tel Aviv, was just recently Microsoft's like big conference over there, and they talk about some of the new stuff coming. ATP is Microsoft's advanced threat protection, like version 3.0 or something. I think they've released it a few times with a different skin, but this new one basically is compiling all of their stuff together into one dashboard on a host. So your machine now, when like you want to go look at firewall, you're going to launch ATP, and you probably can't see it, but in that bottom corner, it's got little boxes for device guard, Windows firewall, credential guard, application guard, exploit guard, kind of all their latest and greatest defenses are now on this one little single dashboard. This idea kind of stems from ATA, which has been out for a little while now. ATA detects all kinds of stuff in the network wide. ATP is kind of like ATA running on every individual host now, so it's going to make it a real pain for attackers to get around that. ATA kind of looks at, it sits on all the DCs in the network, and then any type of thing that interacts with the DC, like authentication request or tickets getting granted or like PSExec, ATA is going to pick up. It does have like a learning curve, I guess. Well, itself does. Like it has to run for 3 weeks to kind of fingerprint your network to see what users are doing. You might get lucky and steal a user that PSExecs all the time, and then it won't detect it. But generally, it detects like a lot of the attacks we talk about here. Like golden tickets, it'll detect like DNS recon. It'll pick up if I query for all the users in the domain. It kind of says like, why'd that user just ask for every user and every group in the domain, and it throws alerts up. And that's somewhat of its downfall, is that it's only like alerts. Like it's a web page you kind of visit, that just, if no one's looking at it, you won't know anything. And that's part of their future plans, are to implement ways you can like isolate events, which there's a lot of like commercial tools I think out now that kind of let you do this, but Microsoft's taking cues from people and implementing it themselves. Again though, it's like one of those things where a lot of that credential guard and stuff is only offered to those Windows 10 enterprise users, and so the rest of us kind of get screwed out of their detection. So that doesn't quite make sense, but I guess they got to make money. But yeah, ATA and then ATP is going to be tough for attackers. There was a talk at Black Hat Europe recently that talked about getting around ATP and ATA as an attacker. He kind of figured out that most of our normal stuff, like net local groups and stuff, is going to get detected. And the scary thing about ATP right now is that ATP is going to start, it uses Windows, I think it's called like DC Diag, but it's the same telemetry data that like all the other Windows stuff uses. It uses that process to feed it up to ATA, and so ATA now has like monitoring on every little host. So we used to be able to do a bunch of host stuff, and ATA would never notice until you actually made a query to a DC. And a lot of those tools have stealth mode, where they'll run, but it'll make sure that it never hits a DC with any of its requests, and that'll kind of keep us under the radar. But ATP is going to be a pain. But luckily, WMI is not able to be logged currently. And that's where ATA's team that talked at Blue Hat was talking about PowerShell 6.0 core is out now, I think, but like 6.0, like the full-fledged, is coming, and they're looking at like, why can't we look at WMI? And they're going to start being able to audit that stuff, but I'm sure some smart people out there will come up with new bypasses for us to use. But for now, yeah, I mean, use WMI if you're doing attacks and you want to stay quiet, because you don't really have to worry about that. Some kind of interesting part about ATP is some of the defenses we've been looking at for an attacker to not get caught is the same stuff that when Windows 10 first came out, everyone was freaking out because they were sending all this telemetry data up to Microsoft. Well, the same like workarounds for ending that work the same for ATP, where like you can redirect simple things like where it's sending it to localhost, and so you never actually send anything to the DC. It all just alerts locally and just runs back to localhost. But so it's definitely got flaws, but it's definitely going to make things a lot harder for attackers. So that's kind of part 3. I know there's kind of a lot of information there, but really, like, you can just jump on a box and run Bloodhound and then the whole path's there. That's kind of usually how easy it is. We don't have to do a lot of the hard stuff. It's good to know the manual stuff, because Bloodhound, like when you grab sessions, it's only like a snapshot of the network. And so a lot of times you have to keep on running it like over and over and over until you find your DA logging in or whatever you're looking for. So the host enum, network enum, and identify a path to DA. And then next time, the final, we're going to kind of hopefully slide into the DCs and pull all the user's passwords, kind of look at DC sync, and I haven't had a chance yet to figure out DC shadow. That's the new one you kind of mentioned on. It's something like a DC sync, but you can like edit any object in the whole domain. But we'll look at pulling all the passwords from all the users once we get those domain admin creds. I've started to kind of try to gather all the references I use in these slides. There's kind of a general commands one up here. I'm sure you can't see that, but if you download these, you can kind of go look at all these references. There's some PowerShell and Active Directory blogs. I bring up adsecurity.org too. That one's really good. These ones were used for like the tokens and ACL stuff, and then tools and GitHub that are mentioned in this talk. And then our roadmap, yeah, next time, we'll also kind of probably look at lateral movement and how we're actually going to move, which WMI is kind of the name of the game now. And that's all for me. A little shameless self-promo as I'm teaching an XSS workshop at B-Sides on 420 coming up. But work at Depth Security, we do pen tests, so if you want to kind of have this revealed to you, we can show you how, but otherwise download the stuff and hit me up on Slack or Twitter or something. Thanks.